In order to analyze the process by using QIIME2, we have to go and see QIIME2 pipeline. Basically, when we download Easy Microbiome and Easy Amplicon from GitHub, it have QIIME2 pipeline inside Easy Amplicon directory. We can go back to our downloaded Easy Amplicon folder. We have here Easy Amplicon master. Just click here and you can see here there is the folder of QIIME2. You just have to see there is the pipeline. Both version is available for Chinese language and for in English language as well. So we have to open this pipeline in RStudio. So what we're going to do, we have to come here in session and set working directory. And then we will see here, we have to set our working directory for Easy Amplicon master in order to open our QIIME2 pipeline in RStudio. We click here, open it. And then we will see here in the result section, we go to the result directory and see here QIIME2 folder. You can see here, we will see here QIIME2. Yeah, it's here QIIME2. Click over here and open the pipeline QIIME2. Click here, and now parallel to the pipeline of our Easy Amplicon pipeline, we can see here pipeline QIIME2. First of all, in our previous video, we already explained what we need to run the QIIME2 pipeline. First of all, user need to install Ubuntu. I already installed it in my system, so you have to install Microsoft Store and click here, type here Ubuntu, and make sure that your VPN should be switched off. Now you can see here you will choose the latest version of Ubuntu and you just click. Now when you click in any one of them, you will see here and you just click get and installing in your system. After creating your account, it will open in your system, and then make sure you have to do one setting in your turn off. You just use this command, turn window feature on and off. Click over here and you have to make your system Windows. You have to select here Window PowerShell. Windows subsystem for Linux. You have to enable it and OK it. After that, when you've done all these things and you want to run the QIIME2 pipeline, you have to switch your terminal. Right now we are in the terminal of Git Bash. Then we have to choose this terminal, Windows subsystem for Linux. Apply and OK. When you have done this, then you will continue. After open QIIME2 pipeline, we will go back to our working directory, which is Easy Amplicon. We will choose our working directory, Easy Amplicon, and then we will open here a new terminal. Now we are back to our working directory, Easy Amplicon 2. And after that, in order to proceed with the analysis process, first we will go to the appendix section to install some software which need to run this pipeline. So we go to the appendix section first, and then we will create, install, activate, and launch Conda. First of all, for the new user, you have to download and install and launch Conda. By clicking this code, you will start downloading. It will take around several minutes to complete. I already done this step, so maybe it will give some error, because when you have you just need to install once. You don't need to repeat this step again and again. Once you're done with all this installation process, and whenever you want to repeat this analysis, you don't want to do this step again. So it only for the first time. After that, you have multiple methods to install QIIME2 and using Conda environment. And normally it is advised to install Conda virtual environment for Linux and Mac user by using this code as well, because for Windows user it's recommended that you have to enter into Linux environment via VirtualBox. I told you earlier that which arrangement you have to make before running this pipeline, and before installing and launching Conda, you must have Ubuntu, you must enable your Windows subsystem for Linux, and then you should switch off your terminal from Git Bash to Windows subsystem for Linux, and then come to the appendix section and start downloading and installing Conda for the first time. But after that, you just simply write activate QIIME2, then you will come to the QIIME2 environment. You'll see here it's 66% complete now, and it will take some time. You have to wait with patience, and then Now you have, as I told you, I will go with method 2. We have to execute this command first one by one. Let's run this command, and then you have to install and package conda. Execute this code. Now the estimated time will appear here. It will take approximately 20 minutes and 54 seconds. So you have to wait here. This process is time taking, that when you are downloading, installing and activating conda environment and QIIME 2, it will take some time. Now it's about to finish. It's 98% complete, only 2% remaining. You can see it's 99% now, and it will be finished within a second now. You can see here. After that, we will go to the step of installation in a new environment. Now you see here, because I already installed and QIIME 2 in my system, we will execute this code. When you will see such kind of icon, it means it's processing at the back end. So you don't need to press any button. You just have to wait. Now see. After that, we will activate and initialize the environment. So first of all, we will activate conda. Now when we activate conda, you can see here, now we can see before it was base and now it's QIIME 2, and then we will unpack conda as well. When you have done this step, come to the species annotation data training set, and you have to download from the official website. You can download Silva 138.99% OT US full length sequence. So we will execute this code. Now see, it's processing here, and you can see it's running, and the estimated time appear here. It's running so fast. You can see here it will take around several minutes. It's about to finish. Now it's done. You can see here we have Silva 138.99 NC classified QZA saved now. And if it doesn't work, you can use alternative link available here. And then we're gonna use green gene, and we are going to download from the official website, link given here. Now you can see start downloading, and the estimated time is, now see, it's running fastly, and it will take approximately 2 minutes. And if in case this link is not working, you can use alternative link, which is given here as well. Now it's about to finish. After that, we will run this code, and now we have to make changes. Now because as we are in working directory D is the amplicon, you have to make change according to your working directory. So change C to D, and you can change your working directory here according to the name you have for your working directory. Like we have the name easy amplicon, so I'll give name easy amplicon. Make sure the spelling is correct, easy amplicon, and then you will execute the code. Now you see here, we can see here now see, it's created a folder here, QIIME 2. Now download the databases. You can download it. If it doesn't work, the alternative link given here, you can use that one as well. Now you can see here it is GG138 OTUS, and here the name is only GG138 OTUS, and this is GG135 or GG138 OTUS targets. The downloading is done here. Normally, if you don't need to do this, you can start with this link, and then we will come here and we will execute this code. Now see, it start downloading here. You can see here it's running. In order to use the 99 OTUs faster data in the repset file and the 99 OTUs taxonomy.txt file as a reference species annotation, and we have to import reference sequences. In order to import, we will execute this code later when we will done this step successfully. Then we come to this step and we will perform this. is recommended because user have to download all this software before running the analysis process. In case if user can skip these steps and they start running the analysis process first, then in each step they will encounter some errors. To avoid those errors, it is recommended to download all these databases before, and after that you will start running your pipeline and analysis process. So we have done here, and now we will execute this code. You see here we have 99 OTS QZA file, GG138 OTS we have here now, and now we will wait that what we will get here, 99 OTUS QZA, and it's still in process. We have to wait to finish it, and after that we will, in order to import species taxonomy information, we will execute this code. Now it gives you a message imported successfully here. Now come to this step and execute the code. And now you see here reference taxonomy QZA file you get here. And in order to train the classifier full length, we will execute this code. When we done this step, after that, we have, in order to extract primer of amplified sequence and segment of the reference sequence, extract reference read, we will use this command which use primers, and we have to replace your primer according to your study. So you can replace primer with your own primer which you use in your experiment, and you can modify your script according to your experiments. You can replace it. This is the test. You can just test this amplicon file, and after that you can modify as per your research and as per your parameters. You can do it. After that, we have to perform primary extraction for amplified segment of the reference sequences, and we have to extract reference read, and then user can replace their primers here. So this is our test pipeline, and user can modify the script according to their own parameters of the research. Now it's processing here. It takes some time, so you have to wait. In the end of the pipeline, it's already given the issues user can face while running the script of QIIME2 pipeline. So you can see, and the solution is also given here. You can see the solution as well, and then you try again. Hopefully you will not get any error. In case if you get any error, you can take help from the Google and online. Many options is given here for every solution. So just copy your solution and paste in the browser, and then you will get many solution alternatively. So you have to run this and download these databases once you are using initially. After that, you can adjust it based on the filter specified segment, and experiment specific classifier is generated, which will take approximately 7 minutes. Now execute this code. So now we have done with all the downloading and installation of the software. Now we go back to the section 1, and we can start our analysis process of QIIME2. Now, first of all, we have to prepare, set up our working directory, which is D is amplicon QIIME2. We are already in our working directory. So we will say conda activate QIIME2. Let's execute this code. And now see, now we are in QIIME2 environment. Now step by step we will execute the code. And then we already have our sequence file in our C directory, so we don't need to execute this code. In case if you don't have, you will go with first download, and then you will execute the code. Now execute this code. Now why it's showing us error? Because we are in this code we are C is the amplicon, but now our working directory is located in D, so make sure and replace it with D. After that, execute this code. Now generate a manifest file based on the metadata. Import data into QIIME2 in parent3 format. It will take some time. Now you can see here, it's manifest file you can see here. And after that, we are going to generate feature table and representative sequences. Method one is you can data 2 you can use, which is slow but prone to error. So we will use multi-thread acceleration, and then we will use this code. After that, we're going to identify the results using data 2 and import them into the main workflow. Let's wait to run it successfully. When this step is finished, now we are going to identify the results using data 2 and import them into the main workflow by executing these codes. You can see here, we get here table QZA and we get here repc QZA files. And after that, you can choose method 2 as well, in which we can import feature table externally. By executing this code, we can upload the green generated OTU table and representative sequence and convert the text file to biome. Keep in mind that biome version should be 2.1.58, but version 2.17 is not working. It will give you error. So make sure that your biome version should be this one. So after that, you can continue with this code. Now, the next step is statistic for the feature table and representative sequences. We're going to execute this code. It takes some time. After that, we're going to perform alpha and beta diversity analysis under QIIME 2. We have to build a phylogenetic tree for diversity analysis, and the estimated time is given here. Let's execute this code. And you can see here we obtained say feature data. To align repc QZA, we must align repc QZA, and we got unrooted tree QZA, and say phylogeny rooted tree QZA. After that, we're going to calculate code diversity. Now you can see here, it's generating many files. Core matrix result. When we click in, okay, let's come here in our working directory, come here over here, and we can see core matrix result. You see here, we got breakroot assistance matrix, PCOA result, and we got faith PD vector, and we get jacket PCOA result, observed feature vector, Shannon vector, unweighted unifrac emperor, and so on. Now, we're gonna significance analysis and mutualization of intergroup alpha diversity. Now we're going to use alpha diversity rarefaction curve, and we execute this code, and we get the visualization alpha rarefaction QZV file. If in case you get any error in this step, it means that you haven't downloaded the required databases and dependencies successfully. So make sure that you first go to the appendix section and download all the databases, and after that you come to the analysis process step and execute the codes one by one for each process. Now we have done this. Now, in order to significance analysis and visualization of intergroup beta diversity, we're going to execute this code. You can see here we got alpha rarefaction QZV file, and now we are running for beta diversity. Now the next is species composition analysis. We will execute this code. Now it's used Silva 13899 NB classifier. Now it's give error here that invalid value for I classifier 2210 back 1. We can see here what we're going to use VG19 13899 V5 V7. If you get the error here, it's mean that you have 2022.10 dot backbone full length, but you have to make sure that where this file is located. For example, if it can be downloaded here outside the QIIME2 directory, so you have to copy this and paste inside the QIIME2 directory, and after that try to execute this code again. So if you get an error, you have to make sure that where this file is located. Now see, before it gives us error, now after when we place it into the QIIME2 directory, it's run successfully. And now we're going to visualize species annotation by executing this code. And then display data with stack bar chart. Then execute the code in order to display data with stack bar charts. Now, the next step is differential analysis using amplicon, in which we're going to format the feature table by adding pseudo counts. And then it takes some time, and after that we're going to calculate differential feature which specify the type of grouping for comparison, and it will take approximately 1 minute. So in all these pipeline while you are running, you have to make sure that your working directory is accurately, and that so in order when you run the code, it will detect your directory and the respective file are located in your working directory in which you are working. So after that, we're going to merge by genus level and perform statistic. And then we're going to perform the formatting of the feature table by adding pseudo counts again. And it will give us the comp table 16QZA. We can see here it's the table 16QZA. It's the comp table QZA. We will see here. And then in order to calculate the differential genera, specifying the type of grouping for comparison, you have to execute this code. Now see here, comp table 16QZA, you will, while running this code, the output will be this. Now all the generated result you can see here under the QIIME2 directory. You can see here you have the seek folder, you got the GG13802 OTUS, you got classified GG13899 QZA file, and you have core matrix result, and then you generated many QZV file of taxonomy, and then taxa bar plot, and then encom group QZV, and so on like this. So here you have done with your QIIME2 analysis as well.